Hello, welcome to Roger Reviews. I am Roger. I review things. I've mostly been reviewing scientific literature and particularly papers that have to do with microplastics and especially microplastics in our bodies. Well, I've decided to think a little bigger, right? So I'm going to review an entire book now. This is the book. It's called Plastic Ink by Beth Gardiner. And my original thought was I would read this book and I would sort of condense my thoughts about it and do a video. Well, I ended up marking just about every page in the margins in that book, and I was able to narrow it down to about 20 major points. But there's no way I can do this all in one video. So what I'm going to do is go through it chapter by chapter, not like reviewing everything about the book. I'm just kind of using it as a template. The points made in this book, they're not all that different from the normal attacks on plastic, although I have to say this book is very well written. She does a great job of getting to know and getting us to know some of the people who have been involved with the plastic industry. I don't doubt at all that her heart is in the right place when she's writing this book, and I feel the same way when I read this book as I do when I see so many posts on social media, and I see these news articles, and I just think you're just not getting it, guys. There's some really important concepts that are not coming through. Beth even mentioned in various places in her book, she asked for comments from Shell, Denka, ExxonMobil, Saudi Aramco, Sabic, Formosa, Plastics Europe, and 5 other industry groups. And the only comment she got back is that she said Shell cited, quote, fatigue for the stories that continually draw unflattering conclusions. Okay, well, I kind of sympathize with Shell there. And there's certainly been a lot of attacks on plastic, and I guess probably these companies can't respond to absolutely every one of them. Now, I want to make this 100% clear. I am not a representative of any of those companies. So I am not giving you any official corporate line, but I do have a different perspective. I worked for the Dow Chemical Company, primarily doing research on plastics for a couple decades. I retired 4 or 5 years ago, and honestly, I thought I was done with this, but just when I thought I was out, they pulled me back in. I got invited to give a lecture, and I ran into some of these articles that were published about microplastics, and they were just so bad. I don't have any ill will towards Beth Gardiner or anyone else who is making these attacks against plastic. If I didn't understand the scientific literature the way I do, I think I would be doing the same thing. There are a lot of places where I'm just going to agree. There's a lot of things in there that are just true. There are a lot of things that I think are lacking perspective in the way they're presented, both in this book and commonly in the mainstream public discourse right now. And then there are a few things where I'm just completely shaking my head thinking, I have no idea what point you're trying to make here. So that's sort of a long preamble. I'm going to start today with the prologue. Just a brief synopsis of the prologue. The greed of big plastic, which is a tentacle of big oil, forces us to use more plastic than we need or want. So that's a one-sentence summary of what I think was the main point of the prologue of Plastic Ink. The first quote that I want to pull in regards to this is, plastic is a petrochemical, and those making it either are subsidiaries of giant fossil fuel companies or are deeply intertwined with them. So I kind of smiled a little bit when I saw this. I just have to tell this story. I don't think the people involved in this story would mind, but I'm going to change the names to protect the innocent. In about 1999, Dow and Exxon were suing the hell out of each other over the rights to a new kind of plastic called metallocene polyethylene. Both of them thought that they should be able to make it and the other one shouldn't. And there were some very long, very heated, and as I understand it, very personal at the end court cases about this that left some of the participants with a lot more gray hairs than they started with. It was a really trying and very stressful time for some people at Dow, and I'm sure some people at Exxon. Now, this was a little bit before I got there, but this is a story that maybe summarizes the feelings that these two companies had for each other. So one of the senior scientists at Dow, and I'm going to just call him Max, that's not his real name, but he was a witness, an expert witness for Dow, and he just hated Exxon so much at that time, he probably still does. He wanted absolutely nothing to do with Exxon, and all of the younger Dow employees also, just out of maybe respect for him and what he was going through, were also trying to, not give Exxon any support at all, including not going to their gas station. Well, there was a carpool that was coming down to work one day, and they were out of gas. I mean, they weren't going to make it. And the only station that they could stop at, in a near emergency situation, was an Exxon station. And so they stopped there, and my buddy, I'm going to call him George, went in to get, something to drink. So he comes out with this, big plastic cup of some drink. Well, they're putting gas in the car, Exxon gas in the car. And of course, it just so happens that Max, who was making the same commute, came down, he saw them stop there, and he pulled in and just glared at them out his window. And my friend George was so upset and concerned about this, he just took his drink and just poured it out right there on the gas station. So I think that's just kind of gives you an idea of how, what this, maybe another interpretation of the word deeply intertwined. This is kind of how deeply intertwined Dow was with Exxon at the time. I know there are different perspectives, but to me, to kind of put the chemical plastic companies and the big oil companies on the same team, from my perspective, that's a bit of a stretch. Okay, now the other point that she says here is that these big oil and gas companies knew about climate change and they didn't say it. And so I'm going to kind of read this quote. It's not just corporate responsibility, but corporate scandal that offers the most useful lens for this story. And this story is what she's going to tell us about plastic. Big Oil's own defining scandal, pushing to discredit climate science, offers the best template for understanding plastic producers' plans and the threat they pose. Okay, so she's saying that because Big Oil withheld this concern they had about climate change in order to sell more products, that means that everything that corporations say from now on has to be a lie. I mean, that's kind of the logic that I see here. It's like, I don't know how you argue with that, right? So any accusation that anybody makes towards a big oil company or any, deeply intertwined company with a big oil company has to be true regardless of any sort of facts or evidence or anything that anyone at any of these corporations says. It doesn't make any sense. Now, what is true, I think, is that corporations act in their best interest, and they may or may not share information with the public depending on whether they think it's going to be in their best interest. So I do think you should have a healthy distrust of what corporations tell you. I don't think that corporations are going to publish anything in the scientific or the publicly available literature that's going to get them sued. So, it kind of runs both ways. Corporations have big financial interests in public perception. They also have deep pockets. So you can sue them in theory and get a lot of money off of them. Okay. So they're hesitant to tell the truth, the whole truth, and nothing but the truth, but they're also hesitant to tell lies that are going to get them in trouble. And it's kind of the opposite when you look at people who are activists or environmentalists. They really have no accountability for what they say. You know, no one's going to sue someone for making a claim about an effect. Like someone might claim that there's a link between autism and a vaccine, for example. That person is not going to get sued for that because corporations don't win lawsuits against individuals. That's been shown over and over and over. You have to look at every case individually. And people like to point at the climate change. People like to point at big tobacco and say they didn't tell you about the harms of smoking. Well, that doesn't prove anything about the health effects of plastics. You could point at coffee, and coffee was classified as some sort of carcinogen for a while. It was under a big attack, and it turned out to just not be true, right? So was Big Coffee lying when they were actually educating the public that coffee isn't actually, dangerous to drink? There have been other cases. I mean, think about power lines and cancer. Well, autism and Tylenol, for example. Like when Tylenol says, no, look, we have this better study that says this link doesn't hold up. Sometimes the corporations are right. I want to talk more about this relationship between fossil fuels and plastic, because I've also seen this, and Beth didn't do this in her book, but people will say, well, 97% of plastics are made out of fossil fuels. Yeah, you're right. What's your point? And so I think activists, environmentalists have historically taken this sort of shortcut when talking about the energy situation, where you attack fossil fuels and you talk about all the bad things about fossil fuels, and then you say, well, there are alternatives. And that in and of itself is not a case for change. Now, it just so happens that in the area of energy, it is, because the alternatives are better, and I'm going to talk about that. But you really have to go one step further and say how the alternatives are better. And it's that last part that no one is doing when they talk about plastics. So let's start first with what makes fossil fuels evil. Okay, I think just about all of us understand now that using these fossil fuels to create energy is harming the planet. And it's no longer hypothetical, theoretical, this may be coming in the future. Like, we're living it right now, and it's getting worse every day. Why is that? Well, what are fossil fuels? Fossil fuels are just dead plants and animals that have been dead for a really long time, like 10 million to 500 million years. Okay, so they've decayed, they've sunk down under the ground, and they're carbon-rich deposits. They're perfectly natural. They're the end of life after a very long time. Okay, so these fossil fuels are solid, which is coal, liquid, which is oil, and gas, which is natural gas. All of them are mostly carbon, and they're just the millions years old remains of previous life. Mostly things like algae and shrubs and stuff like that, but also, dead animals, dinosaurs, that kind of thing. Okay, so what's so bad about that? Well, what's bad about that is when you burn them, and I'm a chemist, I think of everything in terms of chemistry. So this is the chemical equation for burning. So methane, which is a fossil fuel, it's the simplest one probably, is 1 carbon, 4 hydrogens. And if you react that with oxygen, which is O2, you make carbon dioxide, CO2, and water, H2O. Okay, you also make a lot of energy, which we use to create electricity. Some people use it to power cars. But the point is that when we do this, the energy is the good part. The carbon dioxide is the bad part. That's a greenhouse gas. It goes up in the atmosphere. It acts like a big blanket on the Earth that insulates the Earth and creates this climate change, this global warming. Okay, so we need to slow that down. The other thing is fossil fuel use is unsustainable. So if we continue to use our fossil fuel resources at our current rate, the proven reserves, this is what we're pretty sure we can go get. Like if we just keep mining what we already know is there for coal, we've got about 133 years left of coal if we keep using coal at the current rate. We have a lot of coal. The unproven reserves is what the experts think we could find if we go looking for it. We think that we could reasonably go get, okay? And that's 905 years. Okay, so coal we're actually good for quite a while. Now, I also put the greenhouse gas emissions. Don't worry about those units, but you release a lot of carbon dioxide when you use coal for energy, okay? Oil, we're getting there. Like this is a little over a generation. You know, if we care about a sustainable future, like we can't just keep burning all this oil, right? Natural gas, kind of similar. So, you know, we're looking at about 50-ish years of proven reserves, maybe 75 to 100 years. This is an issue. It's unsustainable. We live on a finite planet. We expect infinite growth. Our population keeps growing. Our material use keeps growing. You know, you can't keep doing that forever. So this is also a real problem with using fossil fuels for energy. Now, the alternative energy is things like wind. Now, wind is going to keep blowing, okay, for indefinitely, well longer than we'll be really lucky if there's still humans around when there's no more wind on the planet, okay? So we don't have to worry about running out of wind. If we used absolutely all the wind that we could feasibly use to generate energy, we would have about 3.75 times as much as our current total energy use. Okay, so that's a lot of energy from wind that is potentially available to us. And the good news here is you use 99% less CO2. It's not 100% less because you still have to make these turbines, right? And you still have to maintain them, but it's way, way less because you don't generate CO2, right? The wind blows the turbine that turns into electricity. There's no carbon dioxide inherently generated in wind energy. Another big one is solar. The sun shines a lot of energy on this planet, something like 1,200 times our current energy consumption rate is available from solar energy, at least in theory. Now, I understand in practice all these things. You have to deal with batteries and transmission losses, all that stuff. But, we're not going to run out of wind. We're not going to run out of sun. There's enough energy there to do everything that we need to do. The final point here. Regardless of whether you use fossil fuels or you use alternative sources, the electrons that are running through the wire have no idea what generated them. Okay, electricity is electricity. It doesn't know where it came from. It's going to light your light bulbs exactly the same way. So the output onto the grid is identical. And in fact, the grid takes the electrical output from all of these different sources, mixes, matches, it doesn't matter. So take-home message is this shortcut that activists use, they just say fossil fuels bad, there are alternatives. Well, that shortcut is valid when you're talking about energy, okay? So those are the three things about alternative energies. You have a dramatic reduction in carbon dioxide release, which is a good thing to reduce greenhouse gas warming. The alternative energy sources are sustainable, and the power that's generated, at least in terms of electrical power, is identical. Now, when you look at plastic compared to alternatives, plastic is derived from fossil fuels, but when you compare it to the alternatives, none of those three things are true, okay? So CO2 is not a reaction product in plastic production. The alternatives are also resource limited. And then finally, the material types are not interchangeable. I'm going to go through those three in a little more detail because I think this is important. So let's start first with this. CO2 is not a plastic reaction product. This might be news to you. Ethane, that's a part of natural gas. That C2H6 on the left there, that is a part of natural gas. We isolate it from the methane that's also in there. We burn the methane for energy, and we use the ethane to convert into ethylene and hydrogen. There's no CO2 on the right side of that reaction, okay? We take that ethylene, we do a polymerization, and there are no byproducts of that reaction, okay? There's no carbon dioxide in this. Now, all of the other types of plastic other than polyethylene, that's almost exclusively true for all of the other plastics. That CO2 is not a reaction product, okay? So really, in the context of making plastic, it's not fossil fuels, it's fossil resources, okay? These are carbon-rich deposits in the earth that we take out of the earth, we do some work on them, and we turn them into plastics. Now, don't yell at me through your screen yet. I am going to get to this. There is a lot of CO2 generated, but it's because we need energy to make these things happen, especially that first step. Now, here's another interesting thing, which I never really appreciated till I started looking at this. Now, if you look at how we make steel out of iron. We make iron out of iron ore, okay? Iron ore is iron oxide, basically. So here's an equation where you take iron oxide and you convert it into iron metal. So how do we do that? We have to get the oxygen away from the iron. And the way that's done is you take Coke, not the Coke you drink, not the Coke that some people do other things with. This is a kind of Coke that is made from coal, and you make it from coal by heating the crap literally out of the coal. So you heat the coal really hot and all of the garbage sort of drains out of there. And what you have left is this active form of elemental carbon. And so what you do is you heat this up, you heat it up together, and that carbon will take the oxygen from the iron, and you have iron metal and carbon dioxide. Well, look at this reaction, guys. What's on the left? A fossil fuel. Coal that turns into Coke, right? What's on the right? Carbon dioxide, a greenhouse gas. Okay, so you don't think of steel and manufacturing as being a fossil fuel driven manufacturing process, but it is. This is inherent to the process. This combustion of carbon, of coal into carbon dioxide is the way we make iron, and we make steel from iron. If we converted the grid 100% to alternative energies, to solar or whatever, we would still make carbon dioxide when we're making steel because it is an inherent part of the manufacturing process. So, what you think of as being a fossil fuel driven manufacturing process, your first thought might be, well, fossil fuels, that's plastics, right? The real thing that's fossil fuel driven is steel manufacture. Now, it's also true for aluminum. Aluminum starts from aluminum oxide. You add coke, which is derived from coal. You make carbon dioxide and aluminum. Now, that one's even harder to do. So you have to add a lot of energy in addition to that, electrical energy that comes from the grid. Okay, so aluminum manufacture is a very high energy and high CO2 emission process. This is our annual global fossil fuel consumption. Okay, this is all of the fossil fuels that we use in the world. We use 7,836 million metric tons of coal per year, almost 8 billion metric tons of coal. We use 4.4 billion metric tons of oil and about 2.8 billion metric tons of gas. Now, that's entire use. A lot of that gets turned into gasoline and get burned in our cars. A lot of it goes to power the energy grid, but a lot of it gets used to make stuff. Okay, now, so for example, if we make aluminum, current manufacturing footprint globally for that is about 866 million metric tons of coal and 70 million of oil and 351 million of the natural gas. Now, the coal, as I pointed out, that's to take the oxygen away from the aluminum ore, the aluminum oxide. The gas is for the power. That's the electric power. If we decarbonize the grid, that gas goes down, the coal doesn't. Recycling of aluminum is huge because you don't need nearly as much energy and you don't need that coke that turns into CO2 when you use recycled aluminum. Okay, so we really need to recycle all the aluminum we can. Steel, even more coal, okay? And that's because we make more steel. We make more iron for steel. Now, that's also about 33% recycled. And again, when you recycle, you don't need the coal and you need less energy. It's less of a big deal for steel. But we really want to recycle all the aluminum and steel we can. Plastic. Okay, so this is what we use for energy. I told you we're going to burn some fossil fuels for energy to make plastic. This is what we use. 44 million metric tons of coal, 149 of oil, and 84 of gas. Okay, so it's very small compared to these metals. I don't have this kind of detail for paper or glass. I wish I could include them, but they would be very low. They'd be even lower than plastic for the annual fossil fuel for energy use. So if you combine the consumption of fossil fuels plus the use of fossil resources, then you get to these numbers here. But if you add all those up, you see that even in terms of what we use as resources and fuel, if you combine them for plastic, it's less than what we use for either aluminum or steel, which is almost all getting turned into carbon dioxide. Okay, point number 2, alternatives are also resource limited. Let's go to this imaginary world where we're not using any of these fossil fuels as fuels. We're only using them for fossil resources, okay? So here's what the resourcing would look like if we, how long could we continue to make plastics at our current rate if we weren't using any of these things for energy, if we were just using them to make plastic. And now you see, 16,000 years for coal, 500 for oil, almost 1,000 for gas. If we just use these things as precursors to plastics, they would last hundreds of years, a really long time. Now, compare that to aluminum. 100 years of bauxite, which is aluminum ore, for proven reserves for aluminum, 300 unproven. Steel, I was surprised by this. We've only got about 70 years left of proven reserves if we continue to make steel at our current rate. Now, that unproven is 333, so probably that will come through. It's probably not an emergency or a crisis, but if you look at it in this regard, that's the one that's going to run out first, is iron oxide, iron ore. Concrete and glass, they're made out of sand and gravel, and nobody knows how much of that we have. It's a lot. There were some reports, I don't know, like 10 years ago, there's a big concern about how sand is a non-renewable resource, and it is a non-renewable resource. It's just that we have a lot of it, so nobody really knows how long it'll last, but it's a long time. Wood and paper are made out of trees primarily, and those are renewable. Okay, so trees are kind of like fossil fuels. It's just that they don't have to die for 10 million years. They only have to die for like 10 seconds before you can start getting the useful bits out of them, and then they're going to grow back, right? So you're looking at about a 30 to 50 year turnaround time as opposed to a 10 to 500 million year turnaround time, right? So, trees are a renewable resource, but only at about 5 times our current use rate. you can't make everything out of trees. You're going to run out of land. So one more thing in terms of, are we running out of resources to make plastics? Well, there are a lot of ways to make ethylene. So the way we currently make ethylene is primarily from ethane, which is good because at our current grid, that's about 1.17 tons of carbon dioxide per ton of ethylene. We can also make it from naphtha. It's less efficient, takes more energy. You have more greenhouse gases in that process. You can also make it from coal, which is done almost exclusively in China. I was surprised by this. I think it's something like 8% of our ethylene comes from coal. And that's a sort of a highly emissive process. We prefer not to do that because you need a lot of energy, you generate a lot of greenhouse gases, but you can do that. And, we have a lot of coals. If that was our only option, we could do that for a long time. Now, you can also make it from sugarcane. You can make it from essentially any plant that you can use to make moonshine. Anything that you can take and ferment into alcohol can then be converted into ethylene. In Brazil, they make, I don't remember now, I want to say it was something like 200,000 metric tons a year of polyethylene from sugarcane. So the local farmers grow sugarcane. There are some subsidies for converting that into bioethanol, which Braskem then purchases, converts into ethylene, and polymerizes into polyethylene. This process, the emissions are very low. Braskem might even tell you they're negative. They could be negative. But it's expensive. This becomes economical when ethylene's at about 78 cents a pound. It's currently around 25 cents a pound. So it's just not economical to do right now. And if we did, polyethylene would cost a lot more. There's also issues other than CO2. You're talking about land usage, water usage. It's not quite as clear-cut winner even from an environmental standpoint as you might think it is. The other thing I'll say is this 0 to 1 tons is for ideal conditions like they have in Brazil. Like they have long growing seasons, they have a lot of precipitation, they have ideal conditions for growing sugarcane, but you can't do this in a desert, for example. It's not like a global solution, but it is a possibility if we have to do this. If we really get desperate, you can make ethylene from carbon dioxide. I didn't realize this either till I looked into this, but it's an electrochemical process. You take carbon dioxide, you turn it into ethylene. It's very highly emissive. This is worse than aluminum, right? But in practice, you're just taking the oxide of carbon and making materials out of it. Just like you take the oxide of iron and make materials out of that. You take the oxide of aluminum, make materials out of that. So this isn't like crazy. It's just we don't have to do this. And it would suck down a lot of energy that we can use to do other things. So why would we do this right now if we don't have to? And with our current grid, yeah, you're taking in some carbon dioxide, but you're spitting out 18 tons of carbon dioxide for every ton of ethylene that you make. So this is not a good process in any way. But my point is, we're not going to run out of carbon. So the idea that, we're resource limited for making plastics, it's just a matter of what extremes we have to go to get to the materials that we need. Okay, let's look at this slide again. This shows that there's much more fossil fuels used for energy for things like aluminum and steel than plastic. So this demonstrates beyond a shadow of a doubt that we should always use plastic whenever we can instead of aluminum and steel, right? Now, obviously the answer to that is no. And it's not just because there are other factors to consider other than just CO2 evolution that go into the environmental impacts. But the biggest thing is These are different materials. If you want to build a skyscraper, you don't want to make the framework out of plastic. You want to make it out of steel. If you want to make a bag, steel's not going to work very well for that. You're going to have to use plastic for that. So that's the final point that I wanted to make here, is that it's not electricity we're dealing with. These are all different kinds of materials. They have very different strengths and weaknesses in their properties, and different things work for different applications. Try this experiment. On a windy day, go stand outside and do your best to make a bag out of the wind. Okay? You can't do it. Go out on a sunny day and see if you can figure out a way to make a bottle out of the sun. It doesn't work, okay? Things are made out of stuff, right? And we have to take something out of the ground, something off the ground, something out of the riverbed. You can't just get something for nothing when you're making materials. So one last thought. I was thinking the other day, isn't it weird how we ended up with the energy structure we did based on fossil fuels? If you think about what we do, we drill a hole deep down into the ground. We pull up some hydrocarbons. We do some distillation to get the fraction that we need. We burn that to make enough heat to heat up water to make steam, and the steam pushes through a pipe and turns this turbine, and that's what makes electricity, as opposed to something like a solar cell where you take the solar cell, put it in the sun, and attach a wire to it. I mean, it's really about all there is to it. And so it seems kind of counterintuitive that we went to all this trouble to make this very complex infrastructure to create electrical energy from fossil fuels in the first place. And then it occurred to me that these alternative energies are only recently economically competitive with fossil fuel energies, and it's because it took us a long time to advance the technology, and the technology is based on a combination of different kinds of materials that we had to sort of get all of these different material types working together to make things like windmills, which are made out of steel, fiberglass or plastic, iron, copper, aluminum, and solar cells, which are an even bigger gamish of different material types: glass, plastic, aluminum, silicon, copper, and silver and other metals. So we kind of had to go through this intermediate stage where we used fossil fuels to get over the hump, to get the technology for these alternative energies to where it was competitive. And it takes all these different materials to do it. It's not that simple to just say, oh, plastic bad, glass good, or aluminum bad, paper good. It's just not that simple. But the most important thing about which material you use for an application is how well it works in the application. So whatever something is made of, chances are really good it's made of that material because that material is very good in that application. So if something's made of plastic, you should probably just buy the thing made of plastic. That's going to be the best material for that application. If something's made of glass, it's made of glass for a reason, okay? The glass is probably going to be the best material for that application. Okay, this was the prologue. There are 11 chapters and an epilogue, and I think I have something to say for each of those. But thanks for watching. There's more to come.